The Pleistocene boasted a variety of incredible, unique animals not seen before and likely never to be seen again. Remains of which have been found here in Kents Cavern, which we will explore later in the video. The sabre-toothed cats are perhaps one of, if not the most famous example of this. Huge, muscular, predatory cats that roamed the plains, taking down prey with their namesake sabre-like canines. The Machairodontinae, the family these sabre-toothed cats belong to, demonstrate a variety of research avenues. How did these cats hunt with such long and cumbersome canines? What were they for? How did they live? And why did they go extinct? In today's video, we will explore a cousin of the iconic Smilodon, Homotherium latidens. For now, let's return to Machairodontinae, the most famous member of which being the aforementioned Smilodon, a resident of the Americas that went extinct at the end of the Pleistocene approximately 11,000 years ago. Analysis of mitochondrial DNA that was retrieved from the bones of both Homotherium and Smilodon show they diverged from one another 18 million years ago, meaning that they are actually not as closely related as one would assume. It is believed that Homotherium evolved from the genus Amphimachairodus in Africa. The oldest Homotherium remains come from the Odessa catacombs in Ukraine and Kubifora in Kenya. Both specimens are around the same age of 4 million years old, so it's currently unknown where the genus actually originated from. While at first Homotherium appears very similar to Smilodon, they are actually quite different. When you look closely, you will notice drastic differences in their characteristic canine teeth. Smilodons are smooth and rounded, while Homotheriums are flat and serrated on both edges. Because of this, the genus Homotherium has been given the common name of scimitar-toothed cat, after the scimitar sword. Unlike Smilodon, Homotherium spread across almost all continents, reaching the Americas, Asia, Europe, and Africa. Both genera were the last two members of Machairodontinae to go extinct at the very end of the Pleistocene around 11,000 years ago. All species with the genera Homotherium were about the same size as a lion. The number of species that can be assigned to Homotherium remains enigmatic due to the limited number of remains. 4 species appear commonly in literature: Homotherium serum from America, Homotherium venezuelensis from you can guess where, Homotherium crenatidens, which is an early European form, and Homotherium latidens. This video will focus on the latter. Our story begins in Val d'Arno, Italy, in the early 1800s when the first Homotherium remains were found. Georges Cuvier came across a single canine tooth. This tooth, however, is not the holotype, a specimen used to define a species. This is actually not a rare occurrence in paleontology. It was especially common in the first 150 years of paleontology, where finds were misidentified or new species would be named twice or even thrice, and the first found remains of the animal would not be named the holotype. For example, the first Neanderthal remains ever found are from Gibraltar and predate the holotype by 8 years. But back to Homotherium. Cuvier thought his canine tooth belonged to a new species of bear and gave it the name Ursus cultridens. We now know, of course, that this canine tooth belonged to an extinct genus of predatory cat, Homotherium, and was in fact wrongly identified. We're here right now in Kents Cavern. So this is a cavern system in the south of England that was opened during the Pleistocene. It provided shelter for ancient humans and ancient predatory mammals like cave bear and cave hyena. It's actually also where the oldest Homo sapien remains from England were found, and is also the type locality for the focus of today's video, Homotherium. So the bulk of excavations in this cave occurred between 1865 and 1880, and they were headed by a geologist named William Pengelly. But the first person to actually excavate these caves was, funnily enough, a priest. So Father John McHenry explored these caves between 1825 and 1829. He was the first person to recognise that the flint tools made by people and the mammal bones were actually found in the same layer, and they were oftentimes touching, which meant that humans, ancient humans, and extinct mammals like woolly mammoths were coexisting at the same time. They were living together. We could talk about Father McHenry's adventures in this cave for hours, but for today we're going to focus on one of his more important discoveries, one of the most important things he found here. In the January of 1926, Father John McHenry was excavating the Wolf's Den chamber, which is just behind me now, happily decorated with Christmas trees for the Christmas shows. And he came across 5 incisor teeth and a single canine tooth. He couldn't understand them, he couldn't identify them, they weren't like anything he'd found before. So he gave them to a famous paleontologist, an eccentric professor at the time, Professor William Buckland. You've probably heard of him, his name gets bounced about around a lot. And he couldn't identify them either. They contacted Cuvier, and we've spoken about him earlier, recognised them as being identical to his bare canine teeth from Italy. McHenry's story unfortunately doesn't have a happy ending. He wanted to have his findings published in a book called Cavern Researchers, but he sadly passed away in 1841 before he could ever get someone to take it seriously. This book was unpublished and his notes were scattered in auction. It wasn't until William Pengelly pieced together his notes some decades later that his original findings could be investigated and McHenry's work excavating Kents Cavern could be continued. The scimitar cat teeth fell into the hands of Richard Owen, the man who just a few years earlier in 1841 coined the name dinosaur. This conference occurred just 5 months after McHenry's death. Owen recognised these 5 canines and 1 incisor as belonging to an unidentified species of feline, and in 1846 used them to describe the species Machairodus latidens, assuming it to be the same genus as other large cats from the late Miocene. It would later be recognised as its own genus, Homotherium, meaning same beast, by Emilio Fabrini in 1890. To add more tragedy to McHenry's story, the holotype no longer exists. It was destroyed during the bombing of the Royal College in 1941, almost 100 years after he died. Luckily, the other 4 canines and incisor McHenry found are still around today. 24 years after Father John McHenry's death, William Pengelly started an excavation with a group of people that would become known as the Great Excavation. William Pengelly knew about the Homotherian canines that had been found, and so for 15 years while he oversaw the excavation of the caves, he kept an eye out for them. Finally, in 1872, 46 years after the original 6 teeth were found, he found 1 canine, pretty much right here where I'm standing. You can see over there, that's the wolf's den chamber where the original 6 teeth were found. You can see that it is in very close proximity to where William Pengelly's tooth was found. That means that out of the 80,000 specimens that William Pengelly excavated over that 15-year period, only 1 single one came from Homotherium. What no one recognised at the time was the unusual nature that these teeth were found in. No Homotherium bones have ever been found in the caves, only the teeth, the canines and the incisors from different individuals. There are thousands of cave hyena bones found in the caves, as well as their teeth. So why is it this predator is so unlikely to leave its bones behind? Why are there only teeth in the caves? It's so unusual. In Europe, the youngest Homotherium latidens fossil date to around 200,000 years ago, and it's generally believed they became extinct around this time. This is apart from a jawbone dredged up in the North Sea that dates to 28,000 years ago, but we will discuss that in a moment. The issue is, Kents Cavern was completely inaccessible 200,000 years ago. The oldest remains from the caves are early cave bear, which lived there between 500,000 years ago and 350,000 years ago. Sometime after this, the entrance the bears took seems to have naturally sealed shut or collapsed, because an unbroken floor of stalagmite sealed off this original breccia layer, and no more mud or animal bones came into the caves at this point in time. The caves would only open again around 45,000 years ago, and it is in layers of earth from this age that the teeth are found. So how did the teeth of an animal that had been extinct for over 150,000 years end up in a cave that was completely closed off when it was around? There are a few hypotheses. Hypothesis number 1, the teeth were washed into the caves. It is possible that a Homotherium individual died 200,000 years ago somewhere close to the closed entrance of Kents Cavern, and then 160,000 years later, around 40,000 years ago, a flood event uncovered the skeleton and washed parts of it into the now open caves. Either only the teeth made it into the caves, or the bones that made it in were eaten by cave hyena, leaving only the teeth. The latter is more likely, as the teeth Pengelly found were discovered in the wolf's den chamber, a part of the caves that was used at the time as a shelter and feeding ground by cave hyena, and the incisor Pengelly found does show some form of gnawing, presumably from said cave hyena. The problem with this hypothesis is that 5 canines were found in Kents Cavern, meaning that this material had to come from at least 3 individuals, which means 3 separate skeletons had to have been washed into the cave from close by, and only their canines remained intact. This seems unlikely. Hypothesis 2. The species Homotherium latidens lasted longer than initially thought. While it is believed that Homotherium became extinct in Europe 200,000 years ago, Homotherium serum from America only became extinct at the end of the Pleistocene, 11,000 years ago. In the year 2000, a Homotherium mandible was retrieved from the North Sea that dates to around 28,000 years ago. This was at a time when Kents Cavern was open. It has been hypothesised that Homotherium still existed in Europe until this time, but were just unbelievably rare. Several issues arise from this, however. This doesn't answer the initial question, why is it only teeth that are found in Kents Cavern? Surely if they were roaming around the caves, their remains other than teeth would be present. The cave line, which was also incredibly rare, has been found many times in Kents Cavern, with remains including mandible and skull fragments. Furthermore, the DNA from this mandible was able to be sequenced, and it was found to be nearly identical to a 50,000-year-old Homotherium serum specimen from Yukon. This has 2 interpretations. Either Homotherium was one singular species across the planet, and that the teeth from Kents Cavern and all specimens from America are simply Homotherium latidens, or, more likely, that this represents a late dispersal back from America from a tiny population of Homotherium serum. Homotherium and Britain are too old to have their DNA sequenced, so for now the question remains unanswered. Hypothesis 3. The teeth were brought in by humans. The remains of Homotherium are absurdly rare in the UK in general. Material has only been found in a handful of UK caves, such as Robin Hood Cave and Victoria Quarry in Derbyshire, or in the Westbury Sub-Mendip in Somerset. The majority of these finds are also teeth, especially canines, a trend very like our specimens in Kents Cavern. Recent research of the molecular structure of the teeth at Kents Cavern strongly suggests that they don't originate from the Devon area, perhaps not even the UK at all. This evidence discredits the first hypothesis and supports another explanation. Perhaps humans, possibly even Neanderthals, took the teeth into the caves. It has been suggested early hominins came across the skeleton of a long extinct Homotherium and took its teeth, only for them to be left or lost in Kents Cavern. This is supported by the state of the teeth, as they show much more weathering than most other bones in Kents Cavern, suggesting they were exposed to the elements for some time. It is possible hominins found this skeleton and were fascinated by its most distinct feature, the incredibly large and sharp canine teeth. From here, it's suggested they were collected and used for jewellery, trade goods, religious worship, or maybe even a form of symbolism. If this hypothesis is true, in many ways, these humans were like the first paleontologists. We know Homo sapiens and even Neanderthals collected fossils like shells and sea urchins, so to think that they took these teeth as well is not far-fetched at all. Whatever the story behind these teeth, they provide a fascinating look into the life and evolution of Europe's scimitar-toothed cats, and a brilliant case study in the complications involved in paleontology. As a science, it is not always the most straightforward of disciplines, with mysteries such as these keeping us on our toes and remaining to this day not always conclusively solved. Whether the teeth were taken into the caves by people or transported through flooding, they remain a perfect example of the wild and wonderful life our planet has boasted, and the complex nature of what happens to this life after death. Thank you so much for watching our video about Homotherium. We thought it was such an interesting story and full of such unique ideas and theories that we couldn't just not make a video on. I thought it was a great way to start my video making journey. If you want any more videos filmed in Kents Cavern or anything of this sort of Pleistocene theme from me, just let me know in the comments and we'll see what we can do. Thank you for watching. See you next time.